In this particular video, this is the homework for page 220 in our workbook for the section 8.1, which is really unit 4, a little confusing on, we're jumping to chapter 8, and then we will be back to chapter 3 and 4 and so on. But we are going to be dealing with points and lines and planes in this section. And so let's just go through the answers, and you can fast forward, rewind as needed, and I'll explain how we do each of these questions. All right, so go ahead and just take a look real quick at number 1. It says give 2 other names for CD. That's line CD. And line CD is going through this plane right here. But you notice this little letter right here. This has an M on it, and that M belongs to that line. So one way we can write this is we can write line M. That's one way we can actually write a line for it. And the other way we write it, obviously, is CD with a two-arrowed line above it, right, like that. That's just the notation we get used to. But there's no other points on here except for C and D. So the only other way to write it is DC. Just reorder the letters in the other direction, and we put this notation above it, which just says that's line DC or line CD are really the same thing. All right, number 2, give another name for plane M. So there's this letter in the corner right down here like this, which is actually referring to the whole plane, right, like this whole sheet of paper. And so there are other ways to actually label a plane, and it's using 3 letters. And so we would actually write it like this, plane, and you can spell it out like that, or you could just kind of you can actually use a symbol like that. And so we would say plane A, C, E. That's one way to do it, A, C, E. Or you could actually go plane. Now, why did I pick A, C, E? It's because they're not in the same straight line. I would not actually want to pick A, C, B because they're on the same straight line, and that doesn't create 2 dimensions. That only keeps it in one linear straight line, one dimension. All right, and so we want to actually create a plane, 3 points that are in sort of a 2-dimension, or it creates a 2-dimension. They're just not collinear. All right, and so right here we have B, E, and C could also work. And you could put them in any order, doesn't matter on the order, C, E, B, whatever. So I'm just going to go like this and go B, E, and then C. And those 3 points could also be, those are really you could do a lot of different combos probably. You could do B, E, and A. You could do C, B, and E, or, you could reorder them in a lot of different combinations. But 3 points, not on the same straight line, that says not collinear, and they're in that same plane. So we wouldn't want to use point D, for example. So there's lots of different options you could put right there. Name 3 points, number 3 right here. Let's look at that one. Name 3 points that are collinear. There's actually only 3 points on all of this that are actually on the same exact straight line. And so that would have to be A, C, and B are all on the same straight line, whatever order you want to put those down in. And then name a 4th point that is not collinear with these 3 points. So it's these 3 right here. Which one is not collinear? And so we would have to pick, you could either pick D or you could pick E as a not collinear, not on the same line, right? And so they're not on the same line, either E or D. You could pick D is not collinear. And linear, the word linear just means line. So collinear is another way that we just say on the same line. They share the same line. They coexist on the same line. Name a point that is not coplanar. Okay, this word right here, coplanar, means on the same sheet of paper, like on the same tabletop, for example. So A, C, and E. Here's A, here's C, and here's E. So which one is not in the same plane? Well, B would actually be in the same plane, the same sheet of paper, right? And so, or the same two-dimensional slice is another way to say that. D is the only one that will not work. Name a point. That's the only point that exists. M is not a point, all right? And even little m is not a point. D is the only one, all right? Let's go ahead and scroll down. We'll look at 5, 6, and 7 here next. All right, check out number 5. It says, what is another name for PQ? So now we're looking at a new diagram over here, and it is PQ. It's a line, not a line segment, and we just want another name for it. So a real quick other way to do this is to take a line and just reorder the letters, right? There might be other options. You see T right there? So you could actually have PT is talking about the same line. That point right there where T is located could be another point on the line. And so it only takes two points on a line to define it. And so right here it says, what is another name for RS? So locate RS. It's this one right here. It's kind of more vertical. And so there's R and there's S. And so there's other ways to write it. There's lots of other ways to write it. It says, what is one way you could do it? Well, you could reorder the letters and call it SR. And that's another way to write it, right? What is another name for it? Well, there's T right there as well. And so you could actually go RT with a line above it. You could go TS. There's lots of different options you could have. All right. Just not Q or P because it needs to be on this line. And it only takes 2 letters. If you wrote down 3 letters, wouldn't work. No, we don't do that. We just do two letters. All right. Name all rays that have an endpoint T. Well, this is quite a few of them because we have endpoint T right there. So there would be one of them. And that particular one right here would be TS. Now, when it comes to rays, order does matter. Okay. You can't go ST and call it a ray. Nope, won't work. So you have to actually have the endpoint letter first. All right, so that would be that one. And then here's one right here. We could say goes this way. And that one right there would be TQ. Maybe I'll write it over here so they're all in the same area. Okay, TQ, and it would have a starting point at T, and it would go through Q, and that's why we write it that way. There's no other way to write that. Okay, here's another color. We'll go this way. All right, and this would be TR, starting at T and going through R, and so we would write it like this, TR, with an arrow on it, and that emphasizes that it's a ray that has an endpoint of T, starting point of T, and going through R. Okay, one more. Here's another color. All right, and so there's really 4 of them on here total, and so this last one would be TP. I think we get the idea. All right. On the diagram, draw planes M and N so that they intersect at line K. All right. And so if I was to erase some of this, let me see if I can just sort of erase my lines there from the previous. Okay, so what I want to do is I want to draw a plane. And so that's sort of tricky, but definitely want to draw a plane. It's like 2-dimensional. This is where it gets a little interesting. Drawing in that intersect at line K. So 2 planes always intersect at line K. Here's more of a like easier one, I guess, is if you had like a plane that looked like this, and then you intersected it like sort of like this. That's one way to do it. But when you go underneath of it and you can't see part of it, it's good to use dashed lines. And so it might look something like that, and trying to make it look more 3-dimensional. And then where would it intersect at? These 2 slices of paper would kind of intersect right there at one line. So 2 planes always intersect, or if they intersect, I guess they could be parallel, but if they intersect, they will always intersect at one line. All right, not 2 lines, not possible. Just simply one. So let's try to put that particular kind of thing on here and label them M and N. So this is tricky and just takes practice being able to draw a plane M intersecting at line K. Okay, so we could have one that would sort of, this would be the intersection. So we could have one going out this way, like that. And then we could have another one that's kind of going out like this, if you wanted to. And I used a different color to try to emphasize that and it has nothing to do with that other line, right? So sort of something like this. All right, your drawing might look way different than mine because that's okay. But that's kind of the idea, is to get one slice to go through another slice. But drawing it on paper, that we haven't been like kind of trained to like do that. I don't know. It's goofy when it asks you, here, sketch these other ones. See if you can sketch some of these easier ones. Here's line segment AB. Your drawing could look different than mine, and that's okay. Here's a line segment. Here's A and here's B. All right. But I'm going to sketch this other thing that goes from B to C, but goes through C. So I'm going to sketch it like this, having it go through C, because it is a ray. So all it is a line segment and a ray, and connected at B, right, like that. It could be any angle. It could be any orientation of this in any shape or form, but as long as it's a line segment and a ray. Okay, what about line K and plane M? If you have a plane, I would like to draw the plane first, maybe. Here's a slice of paper, and put a line through it. Okay, so here's it. A line always goes through a plane at one single point. Okay, so here's, let's call that line K, and this will be plane M. So we label them sort of like this. And this one, you could emphasize that it's behind it by using like dashed or dotted lines, and then it would kind of come out the other side. So that's one way to draw it to make it look more three-dimensional, but again, sort of tricky to draw planes. Probably won't ask you to actually draw or sketch a plane on your actual test, but it's good practice. All right, that concludes our answer key to our homework. Keep up the hard work. You're doing great. And go back, review videos, and look stuff over as needed. Fast forward, rewind as needed.